Hi guys, I hope you're all doing well today. We're going to go ahead and continue on with our chapter 11 unit. We finished off chapter 10 and we're moving on to a unit regarding area and volume of figures. And we're going to actually start off pretty basic, and actually this is a pretty short, it's going to be a pretty short video because all we're really discussing here is area of rectangle and area of a square, which I'm sure you guys already know at this point. However, as always, guys, in our class, we give it a little bit different context, so maybe even though you might not think you can use one of these formulas for the beginning, it's going to be very apparent that you actually can towards the end of it. But let's go ahead and discuss a few of these formulas, guys. So as like I said, we are moving on to area and volume. So the first thing we need to understand here, guys, is the area of a rectangle. So area of a rectangle, I'm sure you guys already know this one. It is base times height. So area is base times height, okay? Base times height, okay? Nothing groundbreaking here. I'm sure you guys already all knew that. And we can also talk about the area of a square as also the area equals base times height. However, I'm going to actually write it slightly different. I'm actually going to write it as area equals side squared, because remember, excuse me, at the end of the day, a square just has each side that is congruent to one another. So I can actually say, instead of base times height, I could just say a equals sides squared. So already, guys, we have our two big formulas for this chapter, or for this section, I should say. So let's see what I mean by we are going to apply it in different contexts. So here, even though it might look and appear that there is rectangles, this isn't necessarily just going to be one formula, because that is not a rectangle. That's a mixture of different rectangles. So we're going to have to go ahead and identify what is the full area of the shaded region. Okay, and there's actually multiple ways of doing this, but one that stands out to me right away, and maybe it already has to you, is to actually break this shape up into three different figures. All right, this is super important here, guys. All the angles are right angles. So this is a right angle here, 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 and here. And even these right here, technically these are going to be right angles as well. Now, why is that important? Well, it's important because we can actually split this up into three separate rectangles, guys. Okay? So just because I don't want this to get cluttered, I'm going to go ahead and erase that. But we have one rectangle here. Okay? We have one rectangle here, and finally one rectangle right there. Okay, so we have three different rectangles. Let's go ahead and find the area for each and every one of those. I think the easiest one to start off with is this one down here. The area of this is going to be base times height, so 12 times 28. Let me go ahead and multiply that out. I ended up getting 336, so 336 units squared. I haven't specified any units, so let's just leave it at units squared. The next one, got to do a little bit of work here, guys. Remember, all right, this is we're using rectangles here. So actually, if I want to know, for example, what this measures right here, well, this would measure the exact same thing that this measured. It's going to be 28. So this is going to be 28 times 28 times the height. So 28 times 10, this is going to give me an area of 280 units squared. Okay, so I have two pieces, and the last one that we're going to have to figure out is this middle portion right here. And we could do that by, well, we first have to identify what's the base and what's the height. Now, you got to ask yourself, what does this measure, and what does this measure, and how would you even get that? Well, let's start off with a few things that we actually know. We know that this was 28. We know that this piece is 8. We know that this piece is 8. So if I want to know how much this is right here, then all I really have to do is subtract 28 minus 8 minus 8, and that's actually going to give me 12 units. All right. Very similarly over here, remember, guys, this was 12, so this is 12. So if I want to know how much this measures right here, all I have to do is 34 minus 10 minus 12. So So let's do that. 34 minus 12 minus 10 gives me 12. So we actually have everything we need. We have a base, we have a height, so that's 144 units squared. Okay, so kind of made a mess here, but let me do some erasing. But we have all the units that we need. We have all of our measurements. So now to find the area of the shaded region, it's going to be area of the shaded region is going to be 280 plus 144 plus 336 for a final answer of, let me go ahead and type that into my calculator, and I ended up getting an area of 760 units squared. Again, guys, when we're dealing with area, always include units squared. And again, that's going to be super important as we move on to volume, which will require us to use units cubed. Okay? So again, guys, nothing super groundbreaking, but it still requires you guys to think about these important components of the question. All right, they're telling you that all these angles are right angles, so I didn't explicitly say, hey guys, we have a bunch of rectangles here. You have to be able to figure that out. Okay, now just because you guys know me and you know how I like to show you guys multiple ways of doing this, some of you may have said, wait a minute, Mr. Trotter, you did a bunch of work, but I totally thought of it this way instead. This is one giant rectangle, so all I really have to do is just find the area of this and find the area of this and subtract it from the area of this big rectangle. Okay, and you guys would be right, you absolutely could do that. You could find the big area for the bigger figure and then subtract those two small chunks and you would have the exact same area. I challenge you guys to go ahead and give that a shot on your own. Alright, the next one, it says find the area of a square whose diagonal is 16. Okay, so we have a square. Alright, it is a square, so all sides are congruent, and they're telling us that our diagonal is going to be 16. Alright, well, let's do some work here. I don't know what this is. Well, but if I don't know what that is, then I don't know what this is. Okay, and if I don't know what that is, I don't know what that is, and I don't know what that is. Okay, but I do know that all four of these have to be exactly the same. That I do know. Why? Because this is a square. So keep those little things in mind, guys. Read those problems carefully. So how am I going to do it? Well, what do I know? I know this is a square, so all the angles are right angles. And if you look closely, guys, if you stop for a second and really analyze this problem, this is a right triangle. But not just any right triangle. That's a 45, 45, 90 triangle. Why? Because the diagonals in a square, guys, cut the square in half. So those are 45, 45, 90 triangles. Okay? So we have a way to work with that, right? In a regular 45, 45, 90 triangle, the legs are x and the hypotenuse is x root 2. Well, what do I have? I have the hypotenuse. That's the x root 2. So what does that mean? That means 16 is equal to x root 2. So all I got to do is divide by root 2, divide by root 2. These go away. But I don't like this denominator of square root of 2. We don't like radicals in the denominator. So I'm going to multiply top and bottom by the square root of 2. So what does that give me? That gives me x equals 16 root 2 over, well, what's root 2 times root 2? Root 2 times root 2 is root 4, or just 2. Finally, I can simplify 16 divided by 2 for an answer of x equals 8 root 2. So I now officially know what each of these measure. 8 root 2, 8 root 2, so on and so forth. I'm not even going to change them all. So what is my area for a square? Area for a square is side squared. So in this case, it's going to be 8 root 2 squared. Well, what does that mean? That means that is 8 squared as well as root 2 squared. 8 squared is 64 times root 2 squared is 2. So my final answer here is 128 units squared. Okay, we found the area of a square. So not so straightforward, guys. I know it's an easier topic, maybe easier than what we've worked with, but you still have to stop and consider some of these factors, guys, like this right here. All right, I'm pretty sure back in the day when you were doing this in middle school or maybe even elementary school, finding the area of things, you didn't really consider 45, 45, 90 triangles. Okay, cool. So let's move on, and I think I'm actually going to finish off with this last problem, guys. Like I said, super short video today. So it says the area of a rectangle below is 80 degrees. So this area is equal to, sorry, not 80 degrees, I'm sorry, 80 units squared. We want to find its perimeter. Well, guys, all this is really asking you is to go work backwards, okay? What do we know? We know that the area of a rectangle is base times height. Do I have the area? Yes, I do. Do I have a base? No, I don't. Do I have a height? Yes, I do. Okay? The only thing I didn't know was this base, so I'm going to call that base an x. So what does that mean? Let's go ahead and put everything where it goes. So the area was 80 equals the base, I don't know it, times 5. Well, if I want to get an, actually I kind of don't like that. I'm going to write it as 5x instead. Okay, same thing, really doesn't matter, because either way, what I would have to do here is divide by 5, so we get an answer of x equals 16. And again, it doesn't take very long, guys. Do a quick check for yourselves. Okay, if we have a base of 16 and a height of 5, does that still give me 80 units squared? It sure does. Okay, so again, guys, nothing too crazy here, but I do want you guys to go ahead and start applying these formulas for area in different contexts. So for now, guys, I'm actually going to end this video. Go ahead and try out the homework tonight that I posted. And other than that, I think we're good, guys, and I will see you on the next one. Take care.